Every ship ever built has a pointed end. The Ark did not. No bow, no keel, no rudder, no mast, no sail, no oars. Nothing that pushed it forward and nothing that turned it. By every definition shipwrights have used for 5,000 years, it was not a ship. It was a box. 300 cubits long, 50 wide, 30 high, straight sides, square corners, sitting flat on the water with no way to choose where it went. Put that in terms you can picture, and it is a 4-story building, longer than a football field, floating. People have argued for centuries over whether the Ark could have sailed. It was never built to sail. There was nowhere to sail to. The harder problem is this. Past a certain length, wood stops working. A long hull flexes with every wave until the joints loosen and the seams open, and the vessel begins grinding itself apart from the inside. The Ark is well beyond that length. It carried no iron, and it had to hold together for a year with everything Noah owned inside it. So the question was never whether he could steer. It is what that box was made of, and how anything built from wood at that size could have survived at all. Part 1. The Ark is made from a wood that appears exactly once in the entire Hebrew Bible, and nobody knows what it was. The instruction is specific. Make yourself an ark of gopher wood. And then the word vanishes. It occurs in no other verse, no other Hebrew text, no inscription, nothing that survives from anywhere in the ancient world. One appearance, and then silence. That silence started early. The scholars who produced the Greek Septuagint, working within a few centuries of the original, did not know either. They refused to name a tree. They rendered it as squared timber, describing what had been done to the wood, rather than what the wood was. The oldest translation we have was already guessing. The strongest theory is phonetic. In Hebrew, gopher sits one consonant away from kopher, the word for pitch, the black tar the Ark was sealed with. The two words appear within a single verse of each other. If they are connected, then gopher was never a species at all. It is a description of treatment. Timber prepared with pitch, resinous wood, wood made waterproof. Cypress is the traditional guess. It resists rot, it grew across the region, and shipwrights used it for centuries. But it rests on plausibility, not evidence. No ancient source connects cypress to this word. And there is something worth sitting with here. Noah was told to cut a specific tree, and he knew which one. He was not confused by the instruction. We are the ones who lost the word, which leaves the strange situation that we cannot identify the material the Ark was built from, but we can identify exactly what it was covered in. Part 2. The Ark was sealed with tar, and the instruction to do it is one of the most technically precise lines in the Bible. Cover it inside and out with pitch, not the outside, both faces of every surface. That is a genuine waterproofing specification, and it is the correct one, because a coating applied to only one face of a plank fails the moment the wood swells behind it. The Hebrew word is kopher, and it means bitumen. Natural asphalt, the heavy black tar that pushes up through the ground wherever oil deposits sit close to the surface. Mesopotamia had it in enormous quantity. The seeps it hit on the Euphrates supplied builders for thousands of years and were still producing when Herodotus wrote about them. Stop and consider what that instruction actually is. At the very beginning of recorded civilization, a man is told by name to use a petroleum product. Not to invent it, not to search for it, but to use it, as though the one giving the instruction already knew the material was there in the ground waiting. It was not brushed on cold. Bitumen had to be heated until it flowed, then cut with sand, with lime, and with chopped reed or straw. Those additives are what stop it cracking in the cold and running off the hull in the heat. When chemists analyzed ancient samples, they found that the mixture used to coat boats was essentially the same mixture used as mortar in Mesopotamian buildings. The same substance held the walls up and kept the ships dry. And we have the physical evidence. At a site called H3 in northern Kuwait, excavators recovered 35 fragments of hardened bitumen, dating to somewhere between 5,300 and 4,900 years before Christ. Reed impressions are pressed into one face of them. Barnacles are fixed to the other. That is the skin of a boat. The vessel itself rotted away thousands of years ago, and only its waterproofing survived, carrying the imprint of what it was made of on the inside, and the marks of the open sea on the outside. 7,000 years ago, and the technology was already routine. But bitumen has one weakness, and it changes how we should picture that year afloat. The coating does not last. It cracks, it lifts, it has to be renewed. Mesopotamian crews recoated their hulls again and again, and when a vessel was finally retired, they scraped the bitumen off and stored it to use on the next one. Sealing a hull was never a finished job. It was work that continued for as long as the vessel stayed in the water, which means the sealing of the ark did not end when the door was shut. Part 3. The ark had exactly one door and one opening, and nobody can translate the word for the opening. The interior specification is short, 3 decks, lower, second, and third, a door set in the side, and a tsohar, finished to a cubit above. Start with the decks, because they are doing more work than they appear to. 3 floors running the full length of a hull are not just space for cargo. Every deck is a horizontal brace, tying one wall of the box to the other, holding the sides apart under the pressure of the water and stopping the whole structure from folding inward. In a vessel with no keel and no frame in the way we would recognize, the floors are the skeleton. The ark is held in shape by the rooms inside it. Then, the door. 1. In the side of a 4-story wall with no ramp described, no second exit, and no way to open it from within because the text says it was shut from the outside. And then the word that has defeated everyone who has touched it. Tsohar comes from a root meaning noon, or midday, or bright light. It is not the ordinary Hebrew word for window, which the text uses later for the opening Noah releases the raven from. Translators have rendered tsohar as window, as roof, as opening, and simply as light, and no 2 major translations fully agree. The problem is the measurement, finished to a cubit above. That either means an opening 1 cubit across, or a gap of 1 cubit left running below the roof line, or a roof pitched to a cubit of rise. Each reading produces a different vessel. A single opening 18 inches wide is close to useless for ventilating 3 enclosed decks holding thousands of living animals. A continuous gap beneath the eaves solves that problem completely. The rabbinic sources went further. In Genesis Rabbah, the compilers preserve an unresolved argument. One reading holds that the tsohar was a window. The other holds that it was a stone, hung inside the ark, that gave off light. That tradition is not archaeology, and it should not be treated as such, but it survives because the ancient readers were stuck on the same thing we are. The text gives precise dimensions for the hull, exact instructions for the coating, and a clear count of the decks. And then, for the one feature that determined whether anything inside could see or breathe, it uses a word that was already a mystery 2,000 years ago. Part 4. The ark is longer than any wooden vessel that has ever successfully worked. And that is measuring it generously in our favor. Take the shortest cubit anyone seriously proposes, and the hull comes out at 437 feet. Take the longer royal cubit, and it passes 500. Either number puts it beyond the point where wooden ships stop being possible. That point is not a matter of opinion. It was found the hard way. The largest wooden ship ever built was a 6-masted schooner launched in 1909 with a hull 350 feet long. She flexed so badly in heavy water that her deck planking buckled and her seams opened. Her owners reinforced her again and again, and for 15 years, she ran her pumps around the clock simply to stay afloat. In 1924, she broke apart in a storm and went down with every man aboard. The failure has a name: hogging. A hull floating in waves is never supported evenly. When a wave crest sits under the middle of the vessel, the two ends hang out over nothing, and the whole hull arches upward. When the crest passes and the middle drops into the trough, the ends lift and the center sags. Every wave reverses the load, and the structure is bent one way and then the other, hour after hour, for as long as it is at sea. Wood tolerates that for a while. Then the joints loosen. The fastenings work themselves free, the seams open, and the vessel begins grinding itself apart from the inside. And here is where the shape of the ark stops being strange and starts being the answer. A ship tapers. The bow and the stern come to a point, which is what lets a vessel cut through water, but a narrow end displaces almost no water, and therefore has almost no support beneath it, while still carrying the weight of its own timber and everything stowed in it. The fat middle of the hull is buoyant and pushes up. The fine ends are heavy and hang down. A ship is fighting its own outline before a single wave reaches it, and the longer you make it, the further those unsupported ends reach out from the middle, and the more violently it works against itself. The ark tapers nowhere. It is full width and full depth from one end to the other. Every single foot of that hull displaces the same volume of water and sits on the same amount of support. There are no fine ends, because there are no ends at all in the way a shipwright would mean it. Only two flat walls. The load that destroyed every long wooden ship human beings ever built is produced by the shape of a ship. And the ark, alone among every vessel in the ancient record, was not built in that shape. Part 5. No tree on earth is long enough to plank the side of the ark, which means every wall of that hull is a field of joints. Work the surfaces out and the scale becomes concrete. Two sides, a floor, a roof, two ends, and three full-length decks come to something over 200,000 square feet of surface at the smaller cubit, and close to 280,000 at the larger one. Plank that at 6 inches thick, add the framing and the internal structure, and you are looking at roughly 140,000 to 250,000 cubic feet of finished timber. In the units, a modern sawmill would use somewhere between 1.5 and 3 million board feet. Translated into standing trees, that is not the tens of thousands sometimes quoted. Mature cypress or cedar of genuine structural size yields a few hundred cubic feet of squared timber each, so the real figure is closer to 1,000 to 3,000 trees. The higher numbers you see repeated come from assuming small trunks, and small trunks are exactly what a hull like this cannot use. Because the number of trees was never the hard part. The size of them was. A mature cypress reaches usable structural dimension in 80 to 150 years. Every tree felled for that hull had been standing since before the man cutting it was born. The forest had to have been growing for a century before anyone knew what it would be needed for. And even the tallest of them falls far short. A good structural trunk gives you 60, maybe 80 feet of straight usable timber. The side of the ark runs 437 feet at minimum, so no plank runs the length of the vessel. Every strake is 5 or 6 lengths of timber joined end to end, scarfed together with long overlapping cuts, and then the next row up is staggered, so its joints never line up with the row below it. Count that across 2 sides, a floor, a roof, and 3 decks, and the hull contains thousands of joints. Every one of them is a place where the timber can move. Every one of them is a potential leak, which brings the problem all the way back around. A long wooden hull fails at its joints, working them loose wave by wave until the sea comes through. And the ark is not a solid object at all. It is an enormous assembly of overlapping pieces, held in line by the decks inside it and sealed by the tar over it, with no iron anywhere in the structure to keep any of it from moving. That is the vessel, not a ship carved from timber, but hundreds of trees, felled over years, cut into thousands of pieces, and fitted together into a box that had to stay watertight for a year. Part 6. There is no metal anywhere in the ark. The instructions name the wood, the coating, the decks, the door, and the dimensions, and never once mention a nail, a bolt, a bracket, or a fastening of any kind. That absence is easy to skip past, and it is the single biggest problem in the build. Thousands of separate pieces of timber, joined end to end and stacked in staggered rows, and nothing described that holds any of them to anything else. We know how it was done, because a vessel built the same way survived. In 1954, an Egyptian archaeologist named Kamal el-Malach was clearing debris on the south side of the Great Pyramid when he broke through into a sealed limestone pit. Inside, packed in careful order, were 1,224 pieces of a full-sized ship, cut from Lebanese cedar and buried around 2,500 years before Christ. It took a restorer 14 years to put it back together. When he finished, it stood 143 feet long, and it was intact. There is not one nail in it. The planks are locked to each other with mortise and tenon joints, rectangular slots cut into the timber with matching wooden tongues driven between them. Thousands of V-shaped channels are carved into the inner faces of the boards, and through those channels the entire hull is sewn together with rope spun from halfa grass, miles of it. The vessel has a flat bottom and no keel at all. The planks were assembled into a shell first, and the internal framing went in afterwards, which is the reverse of how a modern hull is built. And then there is the part that changes everything. A rope-lashed hull gets tighter when it gets wet. The timber swells as it absorbs water. The fibers of the rope swell with it, and every joint in the vessel draws itself closed. A boat like this is not sealed against the water. It is sealed by the water. The longer it stays afloat, the tighter it holds. That is also the answer to the problem that destroyed every long wooden ship ever built. A hull fastened with iron is rigid, and a rigid structure has no way to absorb the bending forces of a wave, except by resisting them until something gives. Metal fastenings elongate, seams tear open, and the vessel works itself apart. A lashed hull does not resist, it moves. It bends with the load and comes back, and the joints stay closed because the rope pulls them closed. The tools that built it were copper and bronze, adzes, bow drills, pull saws, mallets, chisels. Genesis itself names a metalworker before the flood, a man who forged bronze and iron, so the text is not describing people without skill. It is describing people whose entire structural vocabulary was wood, rope, and joinery. Which means the ark was almost certainly not held together in spite of having no metal in it. It survived because it had none. Part 7. Reduce the ark's dimensions to a ratio, and you get 6:1 to 0.6, 6 times longer than it is wide, and a little over half as deep as it is wide. That is not an arbitrary set of numbers. It sits inside the range naval architects still use today for hulls that are not meant to move under their own power. Barges are built to roughly those proportions. So are the hulls of bulk carriers once you strip away the bow. The reason is simple. Something that has to be pushed through water needs to be narrow and fine at the front. Something that only has to stay upright and stay whole wants length for strength, width for stability, and no more depth than it needs. Every ship ever designed is a compromise between going somewhere and staying upright. The Ark refuses the compromise. It gives up speed entirely, gives up steering entirely, and spends everything it saves on the other side of the equation. Look at what that buys. At the smaller cubit, the hull is 73 feet wide and 44 feet deep, and the load sits low in it. A vessel that wide relative to its depth is extraordinarily hard to overturn. To capsize it, the sea would have to lift one 73-foot wall clean over the other, against the weight of everything stored along the bottom of it. It would not be comfortable. With no way to steer, the Ark would drift side onto the swell and roll with every wave that passed under it. Anyone inside would have felt all of it for a year. But rolling is not sinking, and a hull this wide rolls to a point and then stops and comes back. There are studies that have tried to quantify this, and their conclusions get quoted a great deal. I would treat them carefully, because the best known of them was published in a journal committed to the outcome in advance. The proportions do not need the help. They are on the page, in the text, and they describe a shape that modern engineering arrived at independently, for exactly the same reason. Part 8. Noah's is not the only Ark, and it is not the oldest set of building instructions we have. The oldest surviving instructions describe a boat that is round. The tablet is small enough to hold in one hand, 11 centimeters by 6, 60 lines of cuneiform, written in Babylonia, somewhere around 1750 before Christ. It came to the British Museum in 2009 and was translated by a curator named Irving Finkel. In it, a god gives a man named Atrahasis the same warning Noah receives, and then tells him how to build the vessel that will carry him through it. What follows is not a story. It is a specification. The plan is laid out as a circle on the ground. The walls stand a rod high, about 20 feet. The floor covers an area of 3,600 square meters, roughly 2/3 of a football pitch, which puts the diameter somewhere near 70 meters. The text lists the wooden ribs, the stanchions, the quantity of palm fiber rope, and the bitumen, poured in by the bathful, to seal it. That rope figure is worth pausing on. Laid out in a single line, it would run around 500 kilometers, London to Edinburgh. This is a coracle. Round riverboats exactly like it were still being built and used on the Euphrates within living memory, which is the point. The Babylonian scribe was not imagining an exotic vessel. He took the ordinary boat everyone in Iraq knew and scaled it up past all reason. Not every scholar accepts the round reading. The same tablet instructs that the vessel's length and breadth be made equal. And in Babylonian mathematics, length and breadth are the vocabulary of four-sided shapes, not circles. There is a real argument that what is being described is square. The debate is live, and it has not been settled. And there is a third arc. In the 11th tablet of the Epic of Gilgamesh, the survivor of the flood describes the boat he was told to build, and it is a cube. Equal on every side, 120 cubits in each direction, divided into 7 decks and 9 compartments, and sealed, like the others, with pitch and bitumen. So 3 accounts survive from the ancient world, and 3 shapes: a circle, a cube, and a rectangle. Set them beside each other and the engineering separates them immediately. A cube in open water has no long axis and no preferred orientation, nothing to settle it into a stable attitude, and its center of gravity sits far too high above its beam. It would turn under the sea rather than ride on it. A circular hull is genuinely stable, and it is the least efficient shape ever floated. All wall and almost no usable length, and it spins. The rectangle is the only one of the 3 that carries a load along its length, stays fixed in its attitude, and gives its structure something to work with. Same flood, same tar. Same instruction to save what could be saved. And of the 3 vessels the ancient world remembered, only one was drawn in the shape that would have held. Part 9. Put the pieces back together, and a single design emerges, and every decision in it points the same way. No bow, because it was not going anywhere. No keel, because a keel exists to hold a course. No rudder, no mast, no oars, because there was no destination to steer toward and no shore to make for. A shape with no taper at either end, so the sea had no leverage on it. A width more than half again its own depth, so that it could roll and never go over. 3 decks running the full length of it, not merely to hold cargo, but to hold the walls apart. Thousands of pieces of timber, none of them long enough on their own, joined and staggered and sewn together with rope, so that the whole hull could bend with the water instead of fighting it, and pull itself tighter every hour it stayed afloat. And over all of it, inside and out, a skin of tar that had to be renewed by hand for as long as the water lasted. We still cannot name the tree it was cut from. We cannot agree on how long a cubit was, or what the word for its single opening meant. The vessel itself has never been found, and almost certainly never will be. But the description is not vague. It is a set of proportions, a material, a coating, a deck count, and a door, and every one of those choices is the choice an experienced builder would make for a hull that had to survive without going anywhere. Nothing in it is decorative. Nothing in it is for speed. 300 cubits by 50 by 30, 6:1 to 0.6. Every other vessel in the ancient world was built to cross the water. This one was built to outlast it.